In today's lesson, we are going to be looking at annuities. So again, this is a continuation of our previous finance lessons where we've looked at compound interest, both for trying to find the present value as well as trying to find the future value. Now we're going to be adding in another component into it. So an annuity refers to equal payments over equal intervals of time. So this could be payments on a loan, so you're paying off a loan, such as a mortgage, or it could be you're getting money or taking money out of a fund or payouts, such as certain insurances, life insurance. You can kind of get annuities or payouts over regular intervals. So it could go either way, whether you're paying off a loan or you're taking money out. You can kind of think of lotteries where you either take the lump sum or you get a certain amount every year. That's kind of an example of an annuity. So with our annuities, we are going to be looking at using TVM solvers to solve these types of questions. Right? We could do it by hand, but it becomes very repetitive, and it's just the same calculations over and over again. So same kind of values when we looked at the TVM solvers previously. N is the number of deposits, or it's the number of years times the number of periods per year. The I% is the interest rate as a percent. PV is the present value. Now, when we're saving money, we're putting money into the bank, we start off with 0. However, when we're dealing with loans or we're taking out a loan, we usually start with that whatever that dollar amount is. PMT is the regular payments. So this is a new thing to our TVM solvers. We will have a PMT or a payment because that is what an annuity is. Now, when we're depositing money or putting money into an account, we're going to make it our value negative. Right? So we dealt with the negative values before. When we're dealing with a negative value, in this case, again, we're removing money or we're giving money away. It's leaving us and going into an account. For the future value, if we're trying to solve it, or when we start with a certain amount, then again, we solve for it. But when it's a loan, or when we've taken a loan, we are putting the FV or the future value at 0. Because in that case, we want to make sure that at the end of the term, the loan is paid off. PY is still the payments per year. CY is the compounding periods per year. Right? So again, those values are the same as before. So again, nothing new here really, except for the fact that we're adding in the PMT or payments. So let's look at one scenario. So when their son was a month old, and at the end of every month thereafter, Chris and Ashley invested a total of $75 into an RESP, or a Registered Education Saving Plan, that paid 6.4% annual interest, compounded monthly. So we want to determine the amount in the fund on the child's 7th birthday, 10th birthday, and 17th birthday. So we're going to have 3 different calculations that we're going to use our TVM solvers for. So we're going to look at the 7th birthday, the 10th, and the 17th. So let's try to find the kind of key values. Right? Our N is going to be the number of years times the number of compounding periods. In this case, we go back up. Let's kind of highlight some of that information. So it's a $75 payment, 6.45% annual interest, compounded monthly. And we're making monthly payments. So the N value is going to be, in this case, 7 times 12, because it's 7 years, or he's 7 years old, times 12 months in a year. So our N value for the first one is 84. Our percent is 6.45, so that doesn't change. Our PV, we're starting with 0. Our PMT is 75, but we're going to make it negative because we're depositing the money. The future value we don't know, that's what we're going to solve for. Our PY is 12 payments per year. And our CY is 12 because there's 12 compounding periods in a year. Now, we could go to our TVM solver, but let's fill out the rest. Really, most of it's going to stay the same. 6.45%, 0, negative 75, 12, 12, 6.45, 0, negative 75, 12, and 12. Right, so we're doing new calculations for every scenario. The end value will change because now we have 10 years times 12 months, or 120. And 17 years times 12 months, or 204. Now that we have all sorry about that. Now that we have all our values, we can go to our TVM solver and enter in the values and get our answer. So if we focus on the first one, so the 7th birthday, so N is 84, I is 6.45, PV is 0, PMT is negative 75 because we're depositing it, FV is 0 right now, PY is 12, CY is 12, and we solve for our future value, and we find that we get $7,936.30. Now, the nice thing about this scenario is all we have to do really for the next one is just go and change the end value. So 120. So then our end value, we can just click solve for FV. Now we have $12,595. And if we click on it, just see, and 78 cents. And for our last one, same thing, except we change to 204, solve for FV, $27,696.17. So those are the different amounts that would be in the fund at the 7th, the 10th, and the 17th birthday. Now, one thing to keep in mind, you're not adding all those values up, right? That $7,936.30 is already incorporated into that 10th birthday amount of $12,000. Same thing with that $12,000 into the $27,000 that we have on the 17th birthday. So each one is an individual calculation that gives us the total at that time. We don't have to worry about adding anything. So by the time their son had turned 17, how much of their own money had Chris and Ashley invested? So how much of their own money did they put in? Well, if we kind of look back, we know that there's 24 payment periods, or there's 24 compounding periods over those 17 years. So if I take 204 months and I multiply it by $75, because that's the amount of the payments they're making, we get that in total they would have put in $15,300. So that's how much of their own money they invested. Now, how much interest did their RESP earn? So in this case, we can take our total value after 17 years, $27,696.17. We're going to subtract the amount of their own money that they put in, the $15,000. Sorry, $15,300. So 27,696.17 minus 15,300. We get $12,396.17. So that's how much interest they earned over 17 years, right? So it's almost, well, it's under $1,000 a year in interest. But again, that's pretty decent, especially when you're only putting in $75 a month. That's not too bad. If Chris and Ashley wanted there to be $3,000 saved by the time their son was 17, how much would their monthly deposit have to be? So this is going to be slightly different, but we can still use our TVM solver. We're just going to have a different missing value. So the new thing here is that they want to have $30,000 saved. So that means our FV, we're not going to be solving for it because we know how much it's going to be. Our PV is going to be 0, our 6.5% or 6.45% for our I. Our N, because it's still 17 years and it's monthly, it's still going to be that 204. Right? Or that was the 17 times 12, gave us 204. PY is still 12, CY is still 12. And now we can actually go back to our TVM solver and solve for our PMT. So it's all roughly going to stay the same, except we're going to take out the PMT. We're going to put in 30,000. We're going to solve for PMT, and we get negative $81.24. The negative, again, only means that we're depositing it. It's leaving us and going into the account. So in order to have $30,000 saved, they need to increase their monthly payments from $75 to $81.24. So that's not too bad if you consider you're only adding in an extra $6 roughly, but you're going to end up making close to maybe $2,500 difference, right? So $7 a month or $6 a month works out to an extra $2,500 over the course of 17 years. So not too bad in terms of a return. So the biggest thing from this lesson is it's essentially the same idea as the previous ones when we looked at present and future value. The only difference here is that we're including payments, whether they're regular payments, whether we're regular deposits. It could be scenarios where we are withdrawing money regularly, but the idea is now we're including something for the PMT or the payments, which is the part of what an annuity is. It's a regular payment. So again, make sure you understand how to use the TVM solvers, how to find the values for it, because with that, you can essentially solve most of these finance questions rather than having to go through and do those calculations.